If you ever need to replace a broken or non-functioning receptacle, follow these procedures. First, shut off the power at the circuit breaker. We then test to see that the power is off by inserting the voltage tester probes into both slots of the top and bottom outlets of the receptacle. If the light does not glow, we can assume that the power to that outlet has been turned off. But to be sure, once the plate has been removed, it is a good idea to test the outlet again by placing the circuit tester on the terminals on both sides of the outlet, both the top set of screws and the bottom set. Do this just in case the outlet is damaged but is still receiving current. Remove the outlet from the wall by grabbing the mounting straps and gently pull them out. Pay attention to the wires because when we replace the outlet, we will want to replace them the same way. Remember to use a receptacle with the correct rating to match the breaker amperage and gauge wire you're using. To reconnect the wires using terminal screws, strip about 3/4 of an inch of insulation off the end of the wire and put a small loop in the end using common needle nose pliers. Then, wrap the wire around the screw in a clockwise fashion. Pull the wire tight against the screw and make sure the wire loop lays flat against the side. By tightening the terminal screw clockwise, the wire tightens securely around the terminal. This method makes a tight, secure connection. When you're done, gently push the outlet back into the box, folding the wires neatly as you go. It is a good idea to test each outlet right after installing it. Again, use your circuit tester. Insert the ends into the slots of the outlet. If the light goes on, you have current. Now test to see if your ground is working by connecting the hot slot with the ground slot. This test also works by connecting the hot slot with the metal screw on the faceplate. Another great tool for testing the integrity of your newly wired outlet is to use a receptacle tester. This device simply plugs into any outlet. The receptacle tester has 3 lights that illuminate to tell you the wiring status of the outlet. If your outlet is wired and functioning properly, the 2 lights on the right will light up. If you have any wiring problem on this receptacle, it will be clearly indicated. On the tester itself, you are given a chart to see whether you've reversed any wires or whether your hot, neutral, or ground wires are not properly connected. Let's address the question, which way should a receptacle be installed? Which way is right side up and which way is upside down? The truth is that you may install a receptacle any way you choose. Electrical code does not require that you observe any set rule about this installation. Just remember to connect your incoming hot wires from the power source to the brass terminals on the receptacle, not the silver terminals. That being said, you may notice that there is an overall preference in that most receptacles are installed with the ground slot down. This may be done for aesthetic or traditional reasons. One reason why an electrician may insist on installing receptacles with the ground slot up is for safety. Have you ever noticed that the grounding prong on many contemporary plugs is longer than the other 2 blades? The grounding prong is the first part of a plug to make a contact inside a socket when you plug it in, and it's the last to break contact when you unplug it. This is a safety measure built into the plug. Having the socket's ground slot on top puts the ground in the path of first contact if someone or something were to touch it from above. If the ground slot is on the bottom, and if a plug wasn't completely inserted into the outlet, the blades of the plug would become exposed. This would be a potential shock hazard. Having the grounding prong on top adds a measure of safety that could and probably has protected many individuals.
So further to our safety section on testing and making sure that the power is off, it's important to test from hot to neutral, as well as hot to ground, and then neutral to ground. Now that's very important when it comes to troubleshooting. If you've got a problem with the circuit, I need to know all those measurements if you're asking me a question about that. But do test when you're looking for power, hot to neutral, hot to ground, and even neutral to ground. Now, here's a caution on when you're trying to get a good ground from the plate screw, as they show in the material here. It's very hard sometimes to get a good connection to ground using that plate screw because it can be painted. It is painted, and to get a good contact with metal isn't the best way to get onto ground. So the best thing to do would be to take that plate off and try to get your one lead of your meter right onto a ground wire or the metal box if the case is such, and then to the hot wire to see if you've got voltage from hot to ground.